Now, let's see the gear tooth geometry first. But here, you see here, I showed 2 teeth and a number of circles. So the solid circles, okay, solid arcs, basically, you see here, because a portion of the circles. All right, solid ones are for visible circles, but the non-solid lines, non-solid arcs showing the invisible circles. Okay. The first one is the pitch circle, which is the most important one. All right, so I show by dash dot line, dash dot arc like this. Okay, and then the largest one, which is the outside circle, okay, or someone would call addendum circle. Corresponding to that, we have the root circle, okay, or someone would call dedendum circle. Okay, and then the base circle, that's the thing we just talked about in the previous movie. Okay, it is invisible, but it has to be there. It's a very important one. Okay, then in the axial direction, we can define the face width by 2 relationships. The top one is for the US custom unit. The second one is for the ISO unit. Okay, you could just pick up a value in between, okay, safely right in the middle. Okay, this pitch circle, it's about pitch circle. This portion of the tooth surface is called face. And then below the pitch circle is called a flank. All right, and of course we have bottom land and top land. So those are just several terminologies. Okay, so there is an important quantity which I want to specially make. That is a circular pitch. Okay, for circular pitch is defined as the distance between 2 adjacent profiles measured along the pitch circle. It can be, like, why don't I do this? Define the pitch first. So I showed one. Actually, there's another one. Okay, so 2 pitches. One is the circular pitch, as I just mentioned over here. Okay, between 2 adjacent profiles measured along the pitch circle, and so that it has to be the circumference of this pitch circle divided by number of teeth. All right. Corresponding to this one is the base pitch. Base pitch is that when we extend this tooth profile into the base circle, extend the other one to the base circle, then we measure the distance. Okay, the relationship between, it is related to the circular pitch by cosine of pressure angle. We'll talk about that later. Okay, and then this pitch circle can be divided into 2 portions. So 1/2 of that is the tooth profile. Okay, this is the solid part. The other one, okay, this is the tooth thickness. All right, the other one is the space. Okay, basically the width of the space. All right, add them together is the circular pitch. Now, let's define the depth. So between the top land and the bottom land, or between the outside the circle and the root circle, we define the whole depth. Above the pitch circle is addendum. Below pitch circle is dedendum. And dedendum is a little bit larger than addendum. Okay, so from with the addendum and the portion of the dedendum, we can define the working depth. Okay, not the whole dedendum portion. So that leaves us a clearance. Okay, so that leaves us clearance, and this clearance is very important in engineering. Such, we use that for lubrication purpose and also for thermal expansion purpose and some other things. Okay, so from that we can define 4 depths. Okay, quantitatively. All right, 4 depths. Addendum, which is what we gave. Okay, A addendum equals module. And dedendum equals a little bit larger, 1.25 of module. Okay, and then the tooth depth, this entire depth is B plus A. So the clearance has to be B minus A. All right, so all these are defined. And based on the clearance, so that gave us a clearance circle. Okay, it's invisible, but it is there. Okay, and then don't forget, we need to also make a fillet at the root, just for strength purpose, so we can define the fillet radius.